But what the scientists, of course, have quite properly advised us is we now have feedback emissions of methane from the wetlands. It's not going to go away. So they're pointing out, of course, it's time that we got all our other sources of human-driven methanes under control and write down. Ewan Nesbitt, at the end of his article, he says, is there an emergency? He says, yes, there is a methane emergency.
Hello, everyone, and welcome to another episode of the Climate Emergency Forum. I'm your host, Regina, and I'm glad that you're joining us tonight. The causality of what we're going to talk about today in terms of the climate emergency is very important. So we all know the importance of carbon dioxide and how an excess of carbon dioxide in the atmosphere correlates to a warmer planet. One of the elements that so often gets second fiddle, however, is methane. And methane is very, very important to the global warming conversation. It's also very scary because despite the fact that last year at COP26 in Glasgow, over 100 countries signed the Global Methane Pledge, which was to lower methane emissions by 30% by 2030, methane has actually gone up. And methane is produced many number of ways by the extraction and burning of fossil fuel, through agricultural means, especially the cultivation of livestock, through permafrost melt. And what's so bad about it is methane is quite a lot stronger. I think it's by a factor of 80 times stronger, at least in the first 20 years that methane is released into the atmosphere. But that's quite a differential there. It does weaken after that, but still that burst of energy into the atmosphere is absolutely terrifying. And what's even more terrifying is the regions in which we're seeing it. For example, in the Appalachians, with the increased mining for coal, there's been a great uptick in methane emissions in that region. And it just frustrates me so much. I mean, as an American, it makes me so angry when we have so many other means of generating energy, and we're doing this practically medieval method of generating energy, digging into the Earth's core, grabbing coal, and we're so much smarter than that. We really are just so much smarter than that. So it's quite frustrating. So there are other fossil fuel industries that are very responsible for a lot of emission of fossil fuel, especially those that are not part of the major fossil fuel companies that don't have as much oversight. So in the Permian Basin, for example, methane has just shot through the roof by 33% post-pandemic. I know a lot of people were talking, especially in the beginning of the pandemic, of how the earth was rewilding. It's not rewilding. I mean, I hate to say it, it never was. We did have a chance to see what we could do when people stayed home and worked from Zoom and didn't drive so much. But you know what happened? It had the opposite effect. I mean, I'm seeing here in New York City, people aren't taking mass transit. We had people buy cars en masse. We had people buy used cars en masse. And now even here in the Northeast, where people are known for commuting, people are spending hours in traffic because they're afraid of catching COVID. So it's had a terrible, terrible effect. And I know one of the persons on our panel who is expert and has spent so much time looking at methane is none other than Peter Carter. And I really, really am looking forward to what you have to say on the topic, Peter.
Thanks, Regina. Paul and I and a lot of other environmentalists, our worst nightmare has recently come true, and it's a methane nightmare. And the title that we've chosen, Methane Emergency, actually is spot on because I think in February, early this year, Ewan Nisbet. And if there is a world leading expert, it's Ewan Nisbet. He had a pretty long article published in which he sort of explained methane, said that methane in the atmosphere is increasing faster than ever, said that the experts have done their isotope studies and they believe that it's wetlands. Now, wetlands warming and emitting more methane, that's a feedback, and it's a feedback loop. And Nisbet and the others have pointed out in their articles, and there are a few of them, that that's beyond our control. And why I say it's our worst nightmare is that methane is, as you say, very, very potent. It's being obviously emitted constantly, and the main worry for a long time, of course, has been the fossil fuel industry. So, as you mentioned, coal mining emits methane, flaring emits, flaring actually burns methane off as CO2. That's a bit crazy in my view. Much better to close the fossil fuel industry down. And of course, an increasing source of methane, and a very big one now, is natural gas fracking and all the like thousands of miles of pipelines, which are leaking methane, and that's sort of inevitable. And that's called fugitive emissions. Now, the methane really is increased at, and I've heard the scientists say this, at an explosive rate. It was pretty flat for a while, then in 2006 it increased really fast. 2014 it increased again a lot, and then just in 2019 it increased a lot. And it's very appropriate that our great Secretary General, Antonio Guterres, I think a couple of days ago, he made another one of his speeches. And this time he said, it's a life and death struggle that we are in for our survival. And he points out that emissions of methane, our emissions of methane, have increased, not reduced, not even flattened. Unfortunately, there's a lot of sources of methane emissions that human beings give rise to. Livestock is fairly well known. It's a huge source. They breathe out methane. The dairy industry also, manure management, methane, landfills has gone really out of sight with methane emissions. There's mountains of landfills in some of the developing countries. Natural gas coal lines I mentioned. Rice paddies is a big source, and it's warming. So, like natural wetlands, rice paddies are giving off some more methane. Biomass burning is another one. Biofuels is another one. They're all bad. They're all bad. And we have to tend to them all, and we can attend to them all. But what the scientists, of course, have quite properly advised us is we now have feedback emissions of methane from the wetlands. It's not going to go away. So they're pointing out, of course, it's time that we got all our other sources of human-driven methanes under control and write down. Ewan Nisbet, at the end of his article, he says, is there an emergency? He says, yes, there is a methane emergency.
Thank you, Peter. I mean, you ended it spot on. There's a methane emergency. And I really like the fact that you brought out the importance of attending to the methane that we can control, because already we've set in motion that, as you mentioned, there's so many sources of it. And that, to me, just brings up such a feeling of overwhelm. And I think it's important for people in our audience to take this in, but to also hear what Peter said. It's important for us to tend to that which we can control. It's not all of it, it's a part. And so, Paul, I want to hear what you have to say on methane.
Yes, thank you, Regina and Peter. So the levels of methane in the atmosphere pre-industrial was about 700 parts per billion. As Peter mentioned, the most recent numbers are 1925 parts per billion. So that's an increase of by a factor of 2.8 times. Of course, for CO2, pre-industrial, it would hit about 280 parts per million. when we're in a warm cycle of the glacial cycles. Oh, and now we're pushing 420 to 430 parts per million, and that's a factor of 1.5 times. So methane's increased almost double, 1.5 times for CO2, methane 2.8 times. Now, this is a huge problem because methane has a very, very high global warming potential. So each molecule of methane causes far more warming than each molecule of CO2. So actually, how much is the question? Well, this concerned many people, including Peter and myself, over a decade ago, around 2010, 2011, there was a group called the Arctic Methane Emergency Group, which was founded by a couple of people in England, mostly Peter Wadhams and John Neeson. And quickly, Peter Carter and myself discovered it, and we joined at about that time. And the whole idea of this, Arctic Methane Emergency Group, I mean, the name speaks for itself. We're in a methane emergency. That was back then. That was a long time ago when most of the scientific community was not saying that methane was going to be a problem. So, 1925 parts per billion. Now, in terms of global warming potential, the numbers always continues to be misquoted in the media, and it's based on a 100-year time frame. Now, the lifetime of methane is 9 to 12 years, something like that. So, but to put it on the same basis as CO2, which is much longer lived in the atmosphere, they IPCC and others tended to use the 100-year time frame number. And that was 22 times or 24 times or 25 times. That was thought to be that. But the latest IPCC report, the AR6 extensive report, Working Group 1 on the physical science basis, gives a number clearly that a 100-year global warming potential for methane is 34 times. So throw away those 22 or 24, 25 numbers. Those are outdated numbers, they're not accurate. The 20-year time scale was also given, and that's 86 times. So you were right when you were saying about, over 80. Now, on the 1 to 2 year time scale, it's more like 150 to 200 times is the global warming potential of methane. And you can determine that by measuring the absorption lines. Pick a very strong absorption line of methane. You can use a laser to probe it on the peak and have a detector at that wavelength. You can clearly determine that global warming potential is very, very high on a 1 or 2 year time scale. So now the thing about this complicated with methane is that the lifetime varies with latitude, and that's hardly ever talked about in the scientific community. It also depends on how quickly the methane can be spread. So if it's coming out from a source region like the Arctic, it can take time to spread to lower latitudes. There's very little water vapor in the Arctic. It's very dry. And the thing that breaks down methane is the hydroxyl radical, OH star or excited OH. And that is mostly produced from sunlight hitting water in the atmosphere. So with very little water in the Arctic, very little sunlight, even in the summer, the intensity, in the summer you get it produced, but winter, no. The OH radical is in short supply up in the Arctic. So if the methane stays in the Arctic for a period of time, the global warming potential is extremely high. If you're near the equator, there's lots of water vapor, there's lots of sunlight, so there's lots of hydroxyl radical being produced. So the methane lifetime will be much, much shorter at the equator. So it's coming up from wetlands, mostly equatorial based, but that is mitigated. The warming potential is mitigated somewhat by the rapid chemical reactions with OH excited, the radical, which can reduce the methane concentration. So it's definitely a huge problem. I'll finish up at the moment. I just want to say that methane coming out of the Arctic from thawing permafrost is a huge problem, and it's kind of like a smoking gun, if you like it, the methane gun. Will it shoot, or will the methane stay stored in that permafrost? And that's permafrost both on land and under the sea, and including including methane from methane hydrates, which is highly concentrated methane that's encapsulated in the lattice of water, frozen water crystals, usually found deep in the soils or deep under the ocean.
Well, thank you so much for that really expansive explanation of methane. As I started off at the top of the show, it is a complicated topic because, as you mentioned, it reacts, I suppose, differently depending on where it is, its environment. And of course, I'm not sure about the isotopes in the Arctic. I'm not that sciencey as you, Paul, but I do know that trouble is in the Arctic, and we've had shows on that before. And we've said what happens in the Arctic doesn't stay in the Arctic. And the melting permafrost is truly, truly scary. And it's definitely something that we all have to be aware of. So really, thank you so much for bringing that to mind, Paul. So Peter, does methane in and of itself have any health implications, or is it just simply something that's in the atmosphere that warms the atmosphere?
Well, actually, it does have some health implications. Because methane is one of the chemicals that interacts with other chemicals in the air, mostly fossil fuel pollution, which produces ozone. And ozone is another, to me, nightmare greenhouse gas. It doesn't last very long at all in the atmosphere, a lot less than methane. But the problem with ozone is that it has its own feedback. So as warming increases, ozone increases, mainly in the northern hemisphere. And ozone is the most damaging air pollutant that there is. And it also is toxic to plants, which means it's toxic to crops. So yeah, real bad. And the complete insanity about this whole thing is if we were to do what was very best for our own health, all of the climate change emergency would disappear because we eat a lot of beef, a lot of meat. So that's even in China, unfortunately, they eat tons of beef these days. So we would stop doing that. We would all become vegan. We wouldn't put up with fossil fuels because fossil fuels kill 10 million people from air pollution. So we'd say we don't want air pollution, right? So this whole thing really is absolutely crazy. And of course, the most insane thing about it is that we are still digging out fossil fuels. So we're still burning fossil fuels. That is absolutely crazy. And when the Secretary General of the United Nations says we are in a life and death struggle for our survival, gee whiz, short time that everybody woke up. I mean, we've woken up. We've been worried about this for years and years and years. The key message from the accelerating increase of methane, which is absolutely out of sight, is we really do have to shut down fossil fuels. Otherwise, Secretary General is right. We literally won't have a future. The Arctic is also a problem. Of course, the tropical wetlands, I mean, they're hot all year round. So yeah, they're giving out lots more methane with global surface warming. But the Arctic, the subarctic wetlands, they're also emitting more and more methane every year. I watched this from the satellite data. So that's happening. Permafrost methane emissions started years and years ago. But the first time I ever saw them on the satellite data was 2 years ago. And there was quite a lot. And there's not as much this year, but this summer, permafrost has been emitting methane. And permafrost emits, as it thaws, CO2 and nitrous oxide. We are in a nightmare scenario. We really do have to wake up and get real. Everybody has to work together on this one. That's the answer for survival.
Yeah, truer words couldn't be said. So important. We have to work together. We need to stop this fighting that humanity is engaged in, and so much of it is fueled by social media. My gosh, let's, as Peter says, let's wake up. And listen, I really appreciate you. I have to say, I appreciate you educating me on methane. I really had no idea that, I'm almost embarrassed, but I had no idea that these gases mixed and affected things such as ozone, which had a direct impact on our health. So I really appreciate you sharing that. I'm more edified. And honestly, if any of you are watching, if it's something that you learned, maybe click the like button or share this video with a friend and tell your friends what you've learned here on this show. And if you haven't subscribed yet, please do. It really does help us. And I want to close out this important topic by hearing more from Paul.
Coal miners from centuries ago used to be very concerned about what they called coal gas, because when they were mining, removing the coal rock from rock faces of the mine, methane would be leaked, that was embedded in the seams, etc., and pockets was released, and above a certain concentration of a few percent, I believe, it becomes highly explosive. So any spark caused a huge mine explosion. Methane, not what we call natural gas, is a liquefied natural gas. The liquid form of it is essentially methane gas. So 90% plus is methane. There might be some CO2 in it. It's pretty odorless. So they make it smell like rotten eggs by adding chemicals to make it smell, so that if there's a natural gas leak in your house, for example, you could smell and get out, at low concentrations before there's a problem. So natural gas was touted as a bridge fuel, unfortunately, by many politicians and world leaders, and who seeded them with that idea that it was a bridge fuel was, of course, the fossil fuel company, who then wanted to proceed recklessly drilling holes all over the ground, like Swiss cheese, to extract natural gas, or fracture rock and get the methane that escapes from the rock. And it's been so harmful to the environment. So methane is definitely at high concentrations, it's extremely dangerous. It's highly explosive. Methane is produced in great quantities in wetlands because when organic matter that is trapped within the wetlands decomposes by microbial decomposition, if it's under the water, it's lacking oxygen. So the microbial decomposition in an aerobic oxygen-less environment produces the methane, the CH4. If there's oxygen available, then it tends to produce CO2 rather than the CH4. Of course, we've all been following recently this massive pipeline explosions. It turned out it was 2 explosions per pipeline. And we've had tremendous release of methane, bubbling up through the seafloor. It's not that deep, 50 or 100 meters deep. It just bubbles up and enters the atmosphere. It's much less effect on the environment if you flare the methane. If you burn it, don't just let it go up into the atmosphere, you flare it off, you burn it, because that converts it to CO2, and the concentrations are much lower, because the concentrations of methane are much lower. They're at the peak parts per billion level than compared to the parts per million level. So for these reasons, methane is a problem, but we're getting more and more sources. I mean, we've seen huge sinkholes occur in Siberia, on land, these huge, massive sinkholes, and there's high concentrations of methane. And what's essentially happening is the methane is igniting. Concentrations are building up. It's igniting under the ground. It's blowing out a huge plug of dirt. People from faraway villages have seen the flashes. So this is a problem. This is also happening underneath the ocean. The methane class rates, because the oceans are warming and the water's fairly shallow, the heat is going into the undersea sediment, thawing out the methane class rates, and we're getting explosive release of methane. So there's vast amounts of methane in the permafrost. And if a small fraction of it was released, it would take the methane concentration out of human hands. It would basically dwarf all human emissions with large releases. So that's a big concern with tipping points. Methane responding to the warming temperatures and being released from the natural environment in levels far exceeding what humans are putting out. So we're pushing the system to a much warmer, more fragile state. And if we pass these feedbacks, then the methane can concentrations can explode and take it out of our hands. You know, there won't be too much we can do if that occurs. And Peter Wadhams did a very good paper with an economist about, you know, what would happen if it was released over 10 years or over, say, a single burst. And it would cost the economy trillions and trillions of dollars was the result of this study.
Thank you for that, Paul. I think that is so key. You know, we hear so much, especially here in the States from the Republican Party, about how we don't have money to do anything about climate change. It's all pie in the sky. It's fake. Well, they say that we can't afford to do anything about it. We can't afford not to do anything about it because the costs of inaction are so much greater, up to and including all of humanity and many, many, many other living beings on this planet. The costs are too great. We can't be penny wise and pound foolish. And perhaps without humanity, there's a planet, but isn't that really, really sad if it has to be that way? So, as was said earlier by Peter, we have to control the methane that we can control. And another thing that I do want to emphasize is the importance of finding like-minded people, people who care about the planet, people who care about the environment, people you can share your thoughts and feelings with, because this isn't going away. We're going to have this for the rest of our lives. Climate change is going nowhere. So it's going to be important to have people to lean on, to support us in this struggle as we do everything we can to save this planet and all life on it. So I really want to thank you for doing your part by tuning in to this show, and hopefully you tune in to more than just this particular program, but many other of our programs and other valuable programs on YouTube about the climate, because being aware, gaining knowledge is powerful. And we thank you very much. And we hope to see you next time at Climate Emergency Forum.